No clapping.
Oh my.
You weren't letting him go.
5, 4, 3. Welcome to Pre-Calculus and Parabolas with Mr. Wade and your live studio audience. And now it's time for parabolas.
No
Anyways.
sound.
That'd be nice. All right. Actually, there's no studio audience at all. Okay.
I'm gonna find it. Pick it up.
Yeah.
Yeah, do it.
Okay. Now, this is a cone that's been sliced diagonally to create a guess what? Parabola. Right? This was done in roughly 350 BC. Wonder who that could be?
Meniscus.
You know what? It's Meniscus again. All right. Well, again, he was a one-hit wonder. All I did were conic sections, and that was about it. All right. But while doing the conic sections, on the same day he discovered ellipses, parabolas, and hyperbolas all at the same time. All right. And of course, well, you know, I'm sitting around. There's no television back then. All right. So, you know, what else can you do?
Yeah,
Or the cherry races.
Survivor.
Okay. Oh, yes.
Expecting.
Okay. Oh, no, not anymore. Okay, parabolas. Okay, so here's what we're going to do. Let's take a look at the classic drawing. Oh, yes, by the way, of course, it's time for Greek Corner. Okay, that's right. Every day in this chapter almost, we talk about the Greek translation, right? Parabola is Greek for runs alongside. This one isn't quite as obvious as the other ones. I don't know, I guess it kind of runs alongside the cone there. I don't know. The excess makes sense, the falling short makes sense. This one, I can't get in the head of a Meniscus, but anyway, so we came up with runs alongside for parabolas. Okay, whatever. All right, so for this one, let's start off with the classic parabola, and of course the classic parabola would be the one we've talked about many times, which is y equals x squared. All right? And we got this and this. Okay? And of course, this little tip down here is going to be called the what?
Focus.
That is the vertex. Every parabola has one vertex. It's either at the bottom or it's at the top if it's upside down, right? Okay? Now, this thing floating in space over here is the focus. We don't have foci today because there aren't two, there's just one parabola, right? Okay? Unlike the ellipse and the hyperbola that have two foci. All right, so focus, vertex. You may or may not have known this one in Algebra 2. This imaginary line right here. This one is called the, it's kind of like one, but it's called the directrix. Somebody do that in Algebra 2? Anybody do that?
Apparently we all did it.
I remember that.
I don't know. Well, there's a new one maybe? I don't know. So, okay, directrix. That's what we're doing. So now, here is, Meniscus actually didn't know about the directrix. He was long gone by the time this came around. So he knew about parabolas. And here's the deal. If you take these sides and you go on forever, the sides become infinitely close to what again? Parallel. Never quite there, but almost parallel, right? He knew that much, all right? In comes another guy. His name was Pappus. All right? Good old Pappus, all right? Probably call him Pappy for short. So, anyway, Pappus lived in a very famous town, which was the center of science at that time. Where would that be?
Oh, man.
Alexandria.
Pappus of Alexandria, where the great library was, right? All right? He was hobnobbing with all those guys. Socrates and Aristotle and Plato and all those guys.
They had cool names.
And then there was Pappus. Yeah. All right? He didn't do much. But he did find this out. He figured out this is what really makes a parabola. What really makes it a parabola, different from all the other curves. Here's the deal. The distance from the vertex to the focus is the same as the distance from the vertex to the directrix, but that's not it. Okay? The focus in a y equals x squared parabola is actually 0, 1/4. That's the exact focus of just the standard x squared right there. Okay, so if you add that in there, you can put that there. And the vertex is what point? 0, 0. And if the vertex is the same distance to the focus and to the directrix, this would be the equation. And how do you do a horizontal line? Y equals negative 1/4, and so it stays the same distance. Now, it's not just the vertex, though. Here's the amazing part of a parabola. If you pick any random point on the parabola, anywhere, all the points on the parabola are the only points that stay the same distance from the directrix as they are from the focus at all times. This is not really drawn on scale, as you can see. Okay? But it's the same distance between the focus and the point on the parabola and the directrix and the point on the parabola at all times, everywhere. Okay? Probably should have made this parabola a little bit wider actually to make that accurate. Okay? So, all right, so let's verify that. Let's pick a random point and test it out, see if that's really true. Would that be possible? All right, let's pick a random point like, say, 0, 0 is pretty easy. How about 2, 8, okay? 2, wait a minute, 4. Once you know it's 2, there's only one y that goes with it.
Yeah.
Right? It's got to be 2 squared is 4, right? Other points contained in the parabola. 10, what? 10, 100. 12, 144. 13, 169. Right. All the perfect squares are on the parabola.
196.
Okay, exactly. So let's not do a big example. Let's do a small example. 2, 4. If you had to find the distance from 2, 4 down to the directrix, that would be something we did on test 7, known as a what?
Vertical distance.
That is the vertical distance, right? To do the vertical distance, what do you have to do? Okay, basically just do top, what was it? Top what? Top y minus the bottom, and that's always the y. Okay, so let's do that. So let's do 2, 4 to y equals negative 1, 4. Okay, do that in space out there. Okay, let's try it. So the top y is 4 minus, what's the bottom y? 4. And that distance right there would be, is it 4 the same thing as what fraction?
16/4.
16/4. Minus makes a plus, and you get the plus sign's not on right now. You get 17/4, and that's how high that is, okay? You mean to tell me that this over here is going to be 17/4 as well? Let's check that. Don't believe it until you see it. How about 2, 4 to 0, 1, 4? Now this is not a vertical distance, is it? Nor is it a horizontal distance. It's a diagonal distance. The only way to do diagonal